So we are going to solve some problems on energy conservation in this slide. A 500 Newton diver drops from a boat 15 meters above the water surface. Find the diver's speed 10 meters above the water surface. Then find the diver's speed just before striking the water. So we are actually asked to find out the velocity of the diver at two different points as he is jumping off the boat. So let's draw the picture now. So see, this is where the diver is at the beginning, 15 meters above the ground, and his weight is given to us, that is 500 Newton. So as he's coming down at 10 meters above the ground, we have to first find his velocity. Let's denote this point as A. And then right before he strikes the water at the point B, we have to again find his velocity. So let's apply the principle of conservation of energy in this case. So we know when the diver is right at the top, he has all his energy is gravitational potential. And the formula for the gravitational potential energy is given to us as mgh. We know this. So let's find out the value at this point, at the topmost point. So we know the weight of a person is given by mass times gravitational acceleration. And in this case, the diver has his weight 500 Newton. So we can substitute mg with 500 Newton and then multiply it with 15. 15 is the height. So that gives us a value of 7,500 joules as the energy at the topmost point. So 7,500 joules is the energy at the topmost point. All right. Now let's find out what is the gravitational potential energy at the point A. Now at the point A, the gravitational potential energy is going to be at this point, it's going to be again mgh, and in this case the height is going to be 10 meters because it's 10 meters above the ground. So we will be applying the same principle, 500 times 10, and that's going to be 5,000 joules. So we have the gravitational potential energy at point A as 5,000 joules. But since the diver is falling down, so he has a combination of both gravitational as well as kinetic energy at the point A. So if we subtract 5,000 joules from 7,500, so we subtract 7,500 minus 5,000, and that is the amount of energy which is the kinetic energy left inside the diver at point A. So now we know the formula for kinetic energy is given by, kinetic energy is always 1/2 times mass times velocity square. Now this is the velocity at point A of the diver. We can write it as VA square. All right. Now let's put the value for kinetic energy on the left hand side, that's 2,500. And on the right hand side, we are going to substitute the values that are known to us. We know the weight of the diver is 500 Newton, So the mass of the diver is going to be weight divided by gravitational acceleration, and that's going to be 50 kilograms. So we can write 50 kilograms times VA square. Now if I solve it, it's going to be 2,500 on the left hand side, and that's going to be 25 times VA square, right? Divide both sides by 25 and you get 100 on the left hand side, which is VA square. So VA will be 10 meters per second. All right. So our answer for the first question is going to be 10 meters per second. Now let's solve the second question in the next slide. Now in this slide, we will be solving for the second question, which is asking us, then find the diver's speed just before striking the water. So we know that the total height is 15 meters and 500 Newton was the weight of the diver. So we found the gravitational potential energy of the diver at the topmost point as mgh, which was 500 times 15, and that was 7,500 joules. Now, right before it hits the water at this point B, all right, let the velocity be vb, all right. So, right before it hits the water, you can see that the height is going to be 0 at this point, all right. So everything, all his energy, all his gravitational potential energy will be converted into his kinetic energy. So the kinetic energy at point B is going to be 1/2 mvb squared, all right. So we can write, since the gravitational potential energy at the topmost point is equal to the kinetic energy at the bottommost point due to the principle of energy conservation. So we can write 7,500 is equal to 1/2 times the mass of the diver, which is 50, times the velocity square. Now we can solve it. 7,500 is equal to 25 times vb square. Divide both sides by 25. So these two 25s gets cancelled, and we are left with 300 on the left hand side. So if we take a square root of 300, we get, so let's take the square root of 300 and we get 17.32. So you can see the velocity has increased. And that's what happens as it comes down. The more it comes down, it accelerates even more, and its velocity has increased from before. So we have already solved the previous question in which we got the answer of 10 meters per second. Now the velocity is 17.32 meters per second. And that's our answer. A 60 kilogram diver is standing on a 10 meters high diving tower. Find the velocity of the diver at a point on his way, 1/3 of his way down during the dive into the pool. So let's draw the picture. We have a diver here standing at the top at 10 meters above the ground, and his mass is given to us, which is 60 kilograms. And he's jumping off that point, and when he reaches a distance which is 2/3 above the ground, so he is covering a distance of 1/3 of his way down. That means 1/3 of the total height he has covered as he is falling down. So at this point, which is like 2/3 above the ground, we need to find out his velocity. All right. So as you know from the principle of conservation of energy, the total gravitational potential energy at the top should be equal to the total energy at this point, which is a combination of gravitational potential energy plus kinetic energy. All right. So let's find out one by one. First, let's find out what is the total gravitational potential energy at the top, and that is going to be the mass of the person, which is 60, times the gravitational acceleration, which is 10, times the total height, which is 10 again. So it's 6,000 joules. That's the energy. Now the gravitational potential energy at this point, which is like 1/3 of the total height that he has traveled already, at this point, the gravitational potential energy is going to be mgh. So if we just look at the gravitational potential energy at this point, that's going to be 60 is the mass, gravity is 10, height is in this case 2/3 of the total height. So 2/3 of 10 meters. So we put 2/3 of 10 meters for the height. And that is going to be 60 times 10 times 2/3 of 10 meters is 6.66. And if we solve it, you'll get 3996 joules. Now this is the gravitational potential energy at this point. Now if you subtract the total mechanical energy or total gravitational potential energy at the top and this minus 3996, so if you subtract 3996 from 6000, you get the remaining energy 2004 joules, and that is equal to the kinetic energy of the person. So now if you solve it, 2004 equals 1/2 times 60 times v square. That's the velocity square. So if you divide 60 by 2, that's going to be 30. So v square will be, if you divide both sides by 30, it's going to be 2004 divided by 30. And that's going to be 66.8. And now if you take a square root of 66.8, you get 8.173. So velocity will be 8.173 meters per second. And that is your answer.